Hello calculus students. In this problem we're going to approximate the area under a curve of the function x squared over 2 over the interval from 1 to 4 using right endpoints of 3 rectangles. So the picture of this problem looks like this here. N is 3, so we're using 3 rectangles. And you're wondering how we got the 2 and the 3. Well, just remember that if we're going from 1 to 4, then the spacing with 3 rectangles must be 4 minus 1 over 3 rectangles. So you take the length of the entire interval divided by the subdivisions, and you get 3 over 3, which is 1. Since these are evenly spaced, that gives us the delta x, which is 1. Evenly spaced points, that is the base of each rectangle. You can see that the base of each rectangle is 1. 1 to 2 is 1, 2 to 3 is 1, 3 to 4 is 1. Now, if you want to calculate the area of each rectangle, you have to determine the heights. Now, we're doing this from right endpoints. So we'll be using the right endpoints. So this height here is given by 2, and I get the 2 from the point here. It's a point on the curve. It's going to be 2 squared over 2. Similarly, this point, the height of this rectangle, is given by this point on the curve, which is 3 squared over 2. And the height of this rectangle is given by this point on the curve, and this is 4 squared over 2. So the area of each rectangle is given by base times height, and once I sum up the area of all the rectangles, I would have approximated the area underneath this curve, which is the approximation of this integral. So let's just complete that computation. So I take the base, which is 1, that's the delta x, and multiply by the height. So I take the base, which is 1, I multiply it by the height, which is 2 squared over 2. So that gives me the area of this rectangle. To that I add the area of the next rectangle. The base is 1, multiplied by the height, which is 3 squared over 2. That gives me the area of this rectangle. And then to that I add the base times the height of the next rectangle, which is 4 squared over 2. And that gives me the area of this rectangle. Now I just add these together. So I have 1 times 2 squared over 2, which is simply 4 over 2, plus 1 times 3 squared over 2, which is simply 9 over 2, plus 1 times 4 squared over 2, which is 16 over 2. And that gives me 16 plus 9 is 25, plus 4 is 29, so that's 29 over 2. So this integral is approximated by the sum of the rectangles, which gives us 29 over 2. So the sum of these 3 areas gives us 29 over 2, and that's the approximate area under the curve given by that expression. All right, in another video, I will do the same approximation using left endpoints.